All right. So, okay. All right, so I'm going to go ahead and start our lesson. I spent just a couple of minutes during lab throwing our notes into PowerPoint. So now I'm up there, but I can take myself away like real easy and turn it, whoops, turn that on. Or I can put y'all on. See, so it's,
Awesome.
so hey Dylan, because he's not here.
Hi Dylan.
There we go.
I was team leader. I did an awesome job.
Yep, she did great.
Good.
Their egg cracked.
Shut up. Don't tell him that.
Well, our egg almost cracked before I was like, hey, by the way, you might want to put weight on that.
So I'm just going to share the screen now. All right. Just to show y'all real quick what I was talking about. I'm going to move us up here. This is what the review for your Q1 exam will look like. And you guys probably know most of these, but just for fun, we're going to have extra time today. So how about if you know it, just say it. We'll just start here. Ready?
We're playing Jeopardy.
Mm-hmm.
What? No, we're playing
Answer.
Oh.
Wait.
What is the answer?
Science.
Oh.
Now you know where we're going with this?
Yeah.
No.
What's the category?
Theory.
Sciencey stuff. There you go. Now you're following. Now you're catching on. All right, how about this one?
Variable.
Variable.
Boom. Nice. Almost. Almost.
Like digits?
Close. Significant digits.
Digit. Oh,
Right?
you misspelled significant.
Did I?
Yeah, 2 N's. Significant.
Wait.
Good guess.
I'll look at it again.
Grammar Nazi.
Well, if I spell it wrong, I'm not going back and change it. So,
I didn't even see that.
Hail English.
Oh.
No.
how about?
What if you just didn't though?
Just close your mouth.
Not quite, but all right. There was that. I'm just going to pretend that didn't happen. Okay.
Metric.
Metric. That would be right. Metric. Yeah. Okay. All right.
Wait, Miss Comic Sans?
It's whatever font was in here. I couldn't change it. I didn't build the program. I just entered the data. That's all.
Okay. Oh, here. Typo.
Go.
Yeah, that's a typo. Good catch. We catch them all now, so we don't worry about it.
Gotta catch them all.
All right, that was coming from somebody.
Nobody knows the answer?
Do the whole rap, go.
Rock cycle.
Wait, I know it. I can't remember it.
Oh yeah, you
Oh.
that makes more sense.
Never. Yeah, if you
Oh,
make
yeah.
it.
There you go, Lily. I'm counting on Lily here.
I like rocks.
Uh-huh.
Oh, sedimentary. Yeah.
Sedimentary.
Been more than
Stop being a rock nerd.
He's going really clever.
Chalk is an example.
Chalk.
Street.
No, not street.
Sedimentary.
Street.
Sedimentary.
Street. I got it.
My favorite
Organic
rock is
sedimentary to be
street.
specific. Right?
Do not know.
Pay attention.
I said it in a normal.
Oh,
All right, Michael, good job.
Wow.
Oh,
Mhm.
wow.
You all right, Lo?
Thanks for disrupting the class.
Fault. Or not.
I like how fast folks think.
Plate. Plate.
Good job.
Wait. There's like 5 extra underscores.
Yeah,
Doesn't matter.
I just had to make a blank, and so it turns out in this. So.
Volcano.
Earthly feature?
Mhm.
What? Is that a word?
Yes. It's just
Hmm.
Weathering.
Clever.
Yeah.
Yes.
Very good.
that doesn't happen.
Oh, I'm sorry.
Ready? No, I know. I'm good enough.
Good.
What's a
Water
Life
cycle.
cycle. Ow. Why did that hurt so much? That's on video too.
All right, run, Dorothy.
Is this weathering?
Wait, are we
There's
being
carbon gas and there's oxygen. Nitrogen.
Hydrogen.
Yeah.
Y'all. All right.
I got it.
Let's
Stratosphere.
Troposphere.
Troposphere. All righty.
got
calls.
this. Oh, win. No.
Yeah, Kai, good job.
Nebulous,
Cumulus.
Yeah,
Come on.
Come on. Serious black.
I love it.
Cumulus. A thunder.
And I should.
Huge.
Good job. Ethan's killing it. All right, how about this one?
Astronomical unit.
Yeah.
Very good.
Australia.
There you go.
Yeah.
Australia. Yep.
It's Aussies.
Moon. Good call. All right.
The moon is in a satellite.
Yes, it is.
Over the other.
June.
It's orbiting around the Earth.
Earth,
Capital.
Earth,
Capital.
Earth, Rock, Earth.
Oh, you want all four of them?
I knew that too.
I thought you wanted all
I
four.
almost knew it.
It'll be more obvious in the setup of the test, obviously. So.
The Big Bang.
Oh,
Redshift.
Doppler.
Doppler effect.
It's a law. What law?
Hubble's law. Hubble's law.
Yeah, Henry. Hubble's law. Good job.
It said Big Bang Theory.
Did it? Well, you know what I meant. I've had a week, y'all. I've had a week. All right, here we go.
Oh,
Sunspots.
yeah.
I like to move in motion.
Something else.
Relativity.
I
wasn't here.
Relativity.
Reference.
Oh, okay.
Oh wait, I knew that.
I mean, it uses a frame of reference.
Y'all are so entertaining.
I have no clue.
Displacement?
Oh, speed.
Speed?
Oh, acceleration.
Acceleration.
Mhm.
Idiot.
There you go.
Displacement?
Displeasure.
Vector.
Almost.
Oh,
Velocity is a
and
vector.
magnitude.
Velocity is a vector. Yep.
I
All
like
right.
to move it. Oh, I get it. That's so funny.
Fine. I know I'm hysterical.
Acceleration.
Acceleration.
Yeah, that's also.
All right, last one.
What is the other one? The final frontier. I should be paying attention to this.
Orbit? No.
Free fall.
Free
I love that y'all sing it. That's fabulous.
Oh, yeah.
Okay, so that's how you're going to review.
I bought a Tom Tate magazine.
If you have everything on here, you will be good to go. So there are 16 questions, but some of them have parts, like they'd be matching or whatever. But pretty much this is what is covered. So if you do this and you've got it, you're good to go. 47 points, 16 questions. So, all right. So let's look at to close blasted thing. Okay. See, like that. This is, I can see the, here it is. This is the lesson before it. And it gives you, that download there. All right. So,
Why don't you want to share with the other teachers?
what now?
Why don't you want to share out the other teachers?
There are no other teachers. It's just me.
Cool.
I tried to share with Jackie, and it's become an issue. Like, I tried to get it to work for her so that she would have the same grade book I would have, but it doesn't. Oh, there's my little, I'm trying to get this to close. There's my little sad little thing that I'm going to get. Okay, that's going to go away. All right. There you go. So let's roll through this, and then hopefully we'll have time like we did in the first class, and we can watch goofy videos of people falling because of Newton's laws. Yes, that was entertaining. We did that last period. All right. So, YouTube videos of people falling. No, just with the lever. All right, so Newton's first and second laws. So you have Aristotle, Galileo, and Newton. So
Aristotle, Galileo, and Newton are the blanks.
okay, who proposed that force is required to keep an object moving at a constant speed? Okay, so let's think about that.
Are they in the same order?
Why do you think, hold on, let's think about it. Why do you suppose he might have assumed that? Like, what experience in his life do you think, or what experience in your life, because you're experiencing similar things as far as physics is concerned.
Falling on my head.
What do you
That was
Is that a problem? I'm sorry.
so what do you think led him to that conclusion? So say you have a ball and you're outside in a grassy field and you roll the ball, what's going to happen?
It's It's gonna stop.
It's going to stop eventually
Because of friction.
because of friction. So what was Aristotle not considering?
To pull towards the air.
Right, but what does that cause?
Free fall.
Between the ball and the surface it's rolling on,
Friction.
friction. So Aristotle wasn't really considering friction, right? If you think about it, if he was considering friction, he would have, yeah, well, he was thinking about you have to keep pushing something to keep it moving. It needs a constant force. He's probably thinking, well, this force, runs out after some time and you have to reinitiate the force. So,
which isn't technically true.
right.
The only reason it's true is because there's friction.
Right, so that's where the next guy comes in. So this guy concluded that objects not subjected to friction or another force will continue to move indefinitely. And as a side note, I mentioned that Figaro didn't get married until 1786, so he and Galileo never met. God, I hope you get the reference. You don't, you get half the reference. You get half the reference. What is Figaro didn't get married? Huh? Nobody knows.
You have the cat from
One of Mozart's most famous operas, Marriage of Figaro,
No,
was written in 1786. So Galileo was long dead
Poor Galileo.
when Mozart wrote the Marriage of Figaro. So yes, you're talking about Galileo. Okay, so there's also a really good book that I mean to read. Jason read it and loved it. It's called Galileo's Daughter. And Galileo's daughters were nuns. And he had one that he wrote back and forth with, Catholic nuns. And they wrote back and forth a lot. And because there was a lot of tension in Galileo's life, right, about with the church and his scientific views. Like they were at odds. And his daughter was sort of his sounding board for that, as someone who was, part of an order in the church. So it's interesting. It's apparently very, very good. And it's on my list of things to read. But if anybody ever reads it, let me know. Yeah,
I read.
here you go. All right, so the last one's obviously Newton here. And, shh. The camera is on you people, just so you know.
Wait, can you turn it a different way?
No, it's on those two nitwits. So,
You too.
Newton didn't come up with his stuff on his own, right? He built on the discoveries, Michael. He built on the discoveries of the great scientists before him, but he did define mass and force, so yay for him. And he introduced laws of motion and published his results in, does anybody want to try it?
Philosophy Naturalis.
Principia Mathematica.
Principia Mathematica, yep.
Dang it. I was reading
Philosophiae Naturalis Principia Mathematica, which is in what language?
Latin.
For what?
Mathematical principles
Of- Right. So here's our three cool guys. Look at when Aristotle lived. Okay.
They all have like the best beards, and then there's Isaac Newton over here, freshly shaving.
Yep.
Wait for it.
On the
The second one's balding.
Dude,
So look at Aristotle and Galileo. About how much time passed between the two of them?
A lot.
A lot.
Like 100 years?
No, like nearly 2,000, like 1,900 years, close to 1,900
Oh, you're
years.
talking about Aristotle and Galileo.
Yeah.
I thought it was Galileo and
One of
Newton.
them died like the year before the other one was born.
Newton and Galileo, yeah. So Aristotle and Galileo were nearly 2,000 years apart, almost like 1,900 something years apart.
That's a
So,
long
I mean,
time.
Alexa messed it up last time.
Aristotle was
Alexa,
first, right?
what's 1,564 plus 322?
1,500 plus
See?
64 equals 1,564.
Thanks, Alexa.
By the
Here.
way, I am trying to respond from the right place. Is this the device you expected?
Yes, now be quiet. So
she got really mad at me the other day.
did she?
Dude, so I played a video on my phone like the day before, and then I called her an explicit name because she wasn't listening to what I was saying. And I was playing it on my phone, and my phone was not Bluetooth connected. She played the sound of the video over her speaker.
How'd that happen?
Watching. I don't know.
It's terrifying.
She got mad.
The spy.
Kai called me.
So anyway, you got roughly 1,900 years between the lifespans of the two of them, all right? So for that long, for that long, people were thinking like Aristotle was thinking. People were thinking about, things requiring a constant reinitiation of force to keep moving. It took quite some time before we changed that thinking. So we don't know where Aristotle is today. Like, you can't go visit Aristotle's tomb or whatnot. But where was he from? Where did he live?
Britain.
No, Aristotle, Greek. Greek. So,
Wasn't Aristotle.
and how about Galileo? Where is he from?
Italy.
Italy. All right. And you can go see him. He's in Basilica di Santa Croce in Florence, along with Michelangelo, Machiavelli, Rossini, and a whole bunch of other important Italian people. Jackson, who was here last class, said he did a report on Galileo last year, and he said they have his middle finger in Florence somewhere, like a relic, which is odd because usually relics are religious figures, not, secular figures. That's really interesting. Usually if you go to Europe, they have a lot of relics. Like, we have a couple here, but they have a lot. They have parts of people's bodies or things that belong to people. Like, if you go to Budapest, the big central cathedral in Budapest is St. Stephen's, and they have St. Stephen's entire hand in this box. It's really elaborate, and its hand is laying on this box, and they turn the light on like every 15 seconds for 5 seconds. You can look at his hand, and then they turn it off so it doesn't keep degrading. But they have all kinds of things, pieces of people's skulls and, vials containing blood and all this stuff. So Galileo's finger, I'm going to have to look into, because I find that very interesting, because he's not a religious figure, and it's nearly always religious figures. So how about Newton? Where is he from?
UK.
Yeah, not UK necessarily, but we could just say England, because there wasn't really so much a UK then. But yes, Henry.
I just want to say,
It was just cake.
I forgot what I was about to
That's
say.
okay. So Newton is a British dude. He's an English guy, and he went to Cambridge and Trinity and King's School, and those are all still there. Those institutions are all still functioning. Yes.
I remember now. Like, Galileo, he's not like a religious person.
Right. He's secular.
the exact opposite of a
Right.
religious
That's what I was
person.
saying. That's why it's odd that there would be a relic. So I'm gonna have to look it up. Now, if you notice, it says that Aristotle studied at Plato's academy. Do y'all know who Plato is? Yeah, he's like a major Greek philosopher, like a
He's
big thinker.
Like a funny toy for kids.
No, not that one. So he was a big thinker, right? And if you look at Aristotle's quote, you can see that he's not just purely a science guy, because he says, "We are what we repeatedly do. Excellence then is not an act, but a habit." I like that. That's a great quote. That's a good one to live by. So he's obviously a thinker type too, and not just solely sciencey guy. And then you got Galileo. All truths are easy to understand once they are discovered. The point is to discover them. So do you remember what Galileo discovered that was important?
No, it's Sir Isaac Newton.
Do we remember?
No.
Nobody remembers what Galileo discovered?
No, that was actually.
We'll come back to it.
The
Gravity.
stars?
We'll come back to it.
Yes, he
All right,
discovered stars, yes.
I just
Created the stars, sky.
And then Newton says, what we know is a drop, what we don't know is an ocean. That I like. That's very, very true. So you can see Newton today. You can go to his tomb, and it's at Westminster Abbey. And I think, well, he's at Westminster Abbey, and that's in London, right?
take a field trip.
With Queen Elizabeth I, Charles Darwin, Michael Faraday, who we will talk about this year. And I believe Dr. Stephen Hawking is the newest interment. I could be wrong, but I think he is the newest interment inside Westminster. And then William Shakespeare is also at Westminster. So we're talking big, important English people, and Newton is among them. All right, so
Newton must be a big, important person.
yeah. So Newton's first law. According to Newton's first law of motion, the state of blank of an object does not change. State of what? Motion, right. The state of motion of an object does not change as long as the what acting on the object?
Force.
As long as the force, net force acting on the object is what? Zero. Okay. What's net force as compared to force?
The combination of all forces pushing upon it in all directions.
Right. So it typically involves, well, it can involve addition or subtraction, but we usually think of net as a subtraction thing just because of the way it applies to other things outside of physics. So like what Does somebody remember what is a net income? What's net income?
total
Do you remember?
Total income of everyone in the entire nation.
No, that's not it.
That's GDP.
If I asked you, yeah, it's GDP. If I asked you what's your net income? Okay, so your gross income is your salary plus your benefits.
After tax, right?
Yes. So say you make $100,000 with your salary and benefits. That's your gross income. And after you've paid your Medicare tax, your Social Security tax, your federal income tax, your state income tax, your county tax, and anything else, when you're left with, 60 grand, that's your net income. So, yeah, yes.
I actually have a story to tell about like my experience with the first law of motion.
Okay,
So I was once
indulge us. We'll.
Right.
I
Oh,
can't wait.
I want
This
to
is great.
test drive.
I'm excited.
Forgot I needed to gently squeeze the brake without just like slamming it.
Oh,
I almost got a mouthful of concrete.
that'll happen. Yeah. So my similar story would be that when I was a kid, there was like these woods in the back of my neighborhood, and they were way in the back. In between, there was 2 cul-de-sacs that went like this, and it was like one house in the middle, and these woods went all the way out to the marsh because Virginia Beach is all like wetlands, right? So no, this is not the one where I got stuck. I had a beach cruiser because we all did. This is before everybody had mountain bikes. So beach cruiser has big wide tires and big
Massive
tires, big cushy seat. But we would go back there and we would ride these bike trails that the older kids, the teenage kids had built. I mean, they had put like pump tracks in there. They built hills. There were parts of it that got real narrow, went by like a cliff and a drop off. It was great. And there were other bike trails in my neighborhood too. And they were all named after different roller coasters at Busch Gardens, because that was our nearest amusement park. So these were the Loch Ness ones. But there was a very big hill at the end, and it went straight down. I was not allowed to go in them by myself. I did it more than once. I got myself stuck in the marsh once and got in major trouble. So I learned. But before I got stuck, I went down the hill one time, and it was fall, and there were leaves everywhere. And I couldn't see the trail all that well. I just kind of knew where it was. Well, something had happened, and a giant hole had formed in the bottom of the trail. I'm talking like this wide, probably that deep. So Newton's first law, man, I was staying in motion, and I was, Galileo's hypothesis, I was accelerating as I went down the hill. And when I hit the hole with my front tire, my whole bike went, woo, and I went with it. I mean, all the way over, end over end. And I smacked on the ground, and my bike came down kind of on top of me and fell to the side. And yeah, Newton's first law will get you every time.
It explains inertia.
Yes, so that's inertia. It's sometimes called the law of inertia.
You should have crossed out the inertia instead of.
Yeah, it's okay. It's all right. Inertia is the tendency of an object to resist a change in its motion. Inertia, in other words, means an object in motion tends to stay in motion, while an object at rest tends to stay at rest, right? So basically, the only difference between inertia as a definition and Newton's first law is adding the part about the net force being changed or an outside force being unbalanced, okay? Now, if we look at this dude, he did pretty much what I did, except he hit a brick wall and I hit a hole. But I love that he's pointing at the wall the whole time, like he's gonna run into it right here.
Yeah.
See, he's pointing at it like, I'm gonna get you, wall. And then here he's like, whoops, that ain't gonna work. And then here he's like, yep, I'm there. There's the wall. There's the wall. And his bike looks a little jacked up and everything. So,
Oh.
All right, so Newton's second law. Does anybody want to give me number 1? What goes in all these blanks? Who can do number 1? Are y'all good? You guys-
Inertia, matter, acceleration. I don't know what's past that.
Well, I'll read it.
Force, mass, weight, inertia.
No, wait. Read it with the read number 1 with the words in it.
Newton's second law of motion. Mass is a measure of the inertia of an object. It depends upon the amount of matter the object contains.
Excellent. Okay.
According to Newton's second law of motion, the acceleration of an object is equal to the net force acting on it divided by the object's mass.
Okay. There we go.
You
have a question?
Blanks and net force.
Huh?
What? Like for 3 blanks in the notes, like blank, blank, blank. I put like net blank force. Which
Yeah.
Yeah. There was a blank, so you knew it was 2 words.
No, it made 3 words.
Oh, sorry about that. Huh, that's
Can I ask
weird.
a dumb question?
Is it a?
No.
Oh, I don't know. What's your question? And no, I'm sure it's not dumb, but go ahead.
Why
No,
is
it's like a yellow
inertia
jacket.
pronounced like inertia and
I don't like
not inertia?
That's a
Because
great.
English is stupid.
Yeah, because English is bizarre.
Because English is
That's
Like,
inertia.
it should be
English.
Yeah. Oh, it's a little lost. We get those sometimes. Those are those little. They're very non-aggressive, and I'm allergic to wasps, so I don't.
Danny, wasps are wasps.
No, but that unless you like. Oh, and there's a stink bug too. What in the world, guys? So unless like people mess with him, he won't bother. In our old house, we had him in our chimney and we didn't know it. And the first time we lit a fire, they came flying into the house. And there were probably like 30 of them. And Jason and I were running around with shoes and trying to swat them and screaming. If there was somebody filming us, we probably would have made enough money off that video to put us up for life. But he's up there, Henry, but we're not going to worry about it. So if we look at this graphic here, all right, we got this girl and she's pushing the box forward. And she needs a certain amount of force. If she adds a second box, she's only going to be able to move them half as far with the same amount of force, right? And as you can just see that the net force is divided by the math, just like it says in the equation, there's a graphic below that shows you exactly what that looks like. And
I like how my girl doesn't change, like what she looks like in all the entire time.
yeah, she almost looks like Matilda. She's willing them to move, like her fingers are out. I like her. She's cool. So she's got 3 boxes. If she uses the same amount of force, she can only move it a third as far, right? Yeah, go. Next one. All right, so what is the force of gravity acting on an object? What do we call that?
Let's stretch it out.
What was that for?
Exactly.
I need to.
What do we call the force? Hey, y'all. What do we call the force of gravity acting on an object? Yes.
Henry, no.
Wait, thank you, Sydney. I don't know where he's going. I'm just going to let him go. Probably to the bathroom.
Right?
He better not. All right, so he's going to the bathroom. Weight. So weight is the force of gravity acting on an object. Right. Okay, Sydney's got that right. So wait a minute. Think about it. If you go to space, you ride on the next SpaceX rocket or whatever.
Starship's gonna be up in 6 months.
I know. So say you do that. Don't mess with Jason's speaker. He'll kick your rear end. All right. So you get up there. Is your mass the same? Cole, Michael, is your mass the same? Your mass is the measure of the inertia of an object. Mass is the measure of inertia of an object. Weight is the measure of force of gravity on an object. So the mass is how much matter you have. So does your mass change if you go to space? No, but does your weight change?
Yes.
Yes. Okay, so keep that in mind, that weight has to do with gravity. So here you have weight equals mass times acceleration due to gravity. By the way, did everybody see my most amazing t-shirt today? I know.
Wow.
Shannon likes my
I
shirt.
love that. That's actually really cool.
I had to get new t-shirts anyway, and I saw this one. I was like, yes, I'm getting that. Of course I am. And then, so they gave you an example there, which, you know, you've seen examples before. All right, so who can put Newton's first law in their own words? Who would like to do that? Nobody wants to try?
I can.
Oh my gosh.
The first
Okay.
law of motion is there's 2 parts kind of. The first part is an object in motion will stay in motion.
Okay.
Unless acted upon by another force.
Okay.
Friction.
Mm-hmm.
Gravity. And an object.
One thing I know.
No. We're in the middle of class.
An object not in motion will not go anywhere unless acted upon by another force. Or unbound.
When an object in motion stays in motion, I hit a P.
Unless acted upon by another.
Right. An object in motion stays in motion. And what did you say about rest?
An object in rest stays in rest.
Okay, so when you do this, remember that means I'm repeating myself.
Yeah.
Unless acted upon by an unbalanced force. Okay. Everybody gets that one, right? You're going to want to memorize all these, right? They're not terrible.
Yes, they are.
I cannot type. I can't type today.
At this point, it's common sense. But back then it wasn't.
Oh, yeah. All right, so how about this next question? Who can put Newton's second law of motion into your own
I
words?
can't. I think
Cole, why don't you do it then? He's good.
no, he's got it.
I raised my hand.
I didn't. My hands are still in.
Nobody wants to give it a shot? Henry.
I'll do it.
And this is what I wrote. I push it a toy, I question a toy that weighs 10 pounds. But I stack another A toy on top of it and find it twice as hard to push. The net force required is double because of the weight it has.
Okay, so how could we say that? So we could say that the net force is either doubled or divided by what? By what? The net force required to move an object, right? I cannot type today. Right, force required to move an object is what? How do we say that?
It's divided by
the
weight.
net force and mass.
We could also say it's proportional to what?
Yeah, the net force and mass.
Yes. I cannot type.
Yes.
Okay.
Indubitably.
Proportional. Really can't type today. To the mass. Okay, so this has just been like a bad day for me for typing. I need to cut my fingernails as part of the problem. Proportion. Oh, there's why.
Look at science, not music or something.
It's a podcast by Michael Gladwell.
No.
Not Malcolm Gladwell.
I thought you were gonna say Malcolm Gladwell.
Okay.
Stop talking about Malcolm Gladwell.
So if you say you're moving a car and somebody comes along and cuts the car in half, you need what portion of the force that you started with? Half. Okay, say you're moving a car and somebody comes along and brings another car and sticks it on top. Now how much do you need? Double. Okay.
You should really be worried about this.
I know,
I was
like,
gonna say this.
you're like,
Right?
How about they have a tow truck? with
I've been using the force.
It's
I'm
a
a
very
saying.
strong
Which one of
man.
the semi trucks?
you don't want to do it, he'll cut your.
That's true. You know, people could cut cars in half. It's a thing. All right, so it sure it happens. Why not? All right, who would like to tell me how mass and weight are different?
Mass is,
Wait a minute, anybody else or just Michael?
I guess I can do
You
it.
both went? Ethan.
Weight is how much like pressure like gravity is in that.
Right.
I wonder how much something weighs.
you're wrong. So,
Okay, and then what about mass?
Mass is how much inertia is in that actually on top of
Right. How much inertia, and it's also how much what?
how much something
Weighs?
How much matter? Yeah.
Stuff something out.
And it also has to do with the density and all that kind of stuff, right? Like that's all. I can't spell that either.
Right.
Density.
thanks for showing me black.
I can't even let. Later. Okay.
Take the desk rack.
All right. Here we go. So that's your basic. That's your basic concept. So if we look real quick, guys, just before I make you laugh at videos, because this was a shorter lesson, which is really good because I needed to not stress myself too much today. If we
Are we gonna
look,
record our reaction to the videos?
I don't know,
She is.
probably not because it'll record the screen.
More specifically, our.
So if we look here,
20 moments compilation.
if we look here, you guys, all right? So look how many Q1 do we have left? We've got next week, right? And we're gonna meet next week. And then we are going to Ireland and Scotland and we will not be here so long. Farewell. Auf Wiedersehen, right?
Isn't that German?
Yes. So this is how far I've gotten. I've gotten through November 12th, but I'm gonna try and wrap some of this up for you guys. But your first, ooh, I don't want to show you teacher lesson. Whoops, hang on, I want to show you your lesson, not my lesson. There you go. This is what's coming your way. I want you to have an idea of what's coming your way. So for your first lesson when I'm not here, there it goes, boom. All right, so you've got a series of YouTube videos to watch. This is really easy. It just basically nails down every one of these points and see you're on universal forces and it's going to cover what is electromagnetic force because that's one that we're running into. What? Yes, it's all in teacheries, of course. Weak nuclear force and strong nuclear force. And this one right here that says gravity visualized is freaking cool. It's seriously cool. It's a simple thing this guy does, but it's the easiest way to visualize it I've ever seen. He's got like this big ring and he's got like a stretchy fabric over it, and he rolls these silver, like the stainless steel balls that we had that we were rolling down. He does that same kind of thing, and you can see gravity attract two of them. It's really cool. And then this whole video about how centrifugal force doesn't exist. Have you heard of centrifugal force? Centrifugal, not centripetal, but centrifugal. So, okay, so the guy explains it, and it's interesting because really what it is a combination of other things going on. But you know what a centrifuge is? It's like, you know, they use it to spin, sometimes the doctors will use it to like spin blood samples, and it separates it. And you can also go to the one that's a ride when you get in it.
Centrifuge.
Yeah, the centrifuge ride, you stand against the wall and it spins and then the floor drops out, but you're stuck to the wall. Yeah. Right. Yes, Henry? Okay. So there's that. And then this right here, this is the flippity. See, it says that your only thing you're doing after class is beginning your review. So you're going to do that, review, and take the test. Everything that you're doing that you don't turn in next week, anything that isn't due next week, and the only thing due next week are your questions, right? And we may do them in class again so that I don't have to keep them for so long because you turned in your labs today. So anything that is not turned in next week is not due until the 29th when I get back. You don't have to turn in anything online early. You don't have to turn in you don't have to try and send me anything. It's just bring it all when you get back, because I'm not grading when I'm on vacation, y'all. So I don't care. I don't care if you turn it in the day after I leave. I'm not grading it. So that's all there is for that. See, this is an easy one. And you do have notes to go with that first lesson, see? You do have notes. And they're easy notes. See, it's not very many. All right. So let me show y'all. I'm going to stop the share video, but y'all say bye to Dylan or whomever. Bye.
Sayonara.
All right.
Bye.
And I'm going to stop the recording. Okay, we're just going to watch some YouTube Newton's first law of goofiness. All right.
Water. Good.
All right.
Yeah, record most of you butts.